Welcome to Chemistry Simplified. The topic for today is naming ionic compounds. Before we start with the presentation, let's talk about some cations which only have one charge, meaning that their charge never change. So we have silver, normally has a positive 1 charge, aluminum has a positive 3 charge, cadmium with a positive 2 charge, zinc with a positive 2 charge. From the periodic table, as we have learned previously, the alkaline metals in group 1A and alkaline earth metal in group 2As, they do not change their charges. Alkaline metal in group 1A has a positive 1 charge, and alkaline earth metal in group 2A normally has a positive 2 charge. Our first example, we are given the formula Mg3N2. How would we name that? Step 1, magnesium is an alkaline earth metal, so it keeps its original name. We do not change the name. Nitrogen is a monatomic anion, so we will change its suffix to IDE. So instead of nitrogen, we're going to call it nitride. So the name for this compound is magnesium nitride. Example number 2, we are given the formula Na2O. How should we name this compound here? Sodium is an alkaline metal in group 1A, so it's going to keep its original name. Oxygen is a monatomic anion, so we're going to change its suffix to IDE. Therefore, the name would be sodium oxide. Example number 3, Li2CO3. Lithium is in group 1A. It's an alkaline metal, so we keep its original name. Now, CO3 is carbonate ion. It's a polyatomic anion, so it's going to keep its original name. Let's look it up. All right, this is the name, carbonate ion, so we're going to call it carbonate. So the name for this compound is lithium carbonate. So you need to memorize the name of the polyatomic anion, so you could be familiar with them, so we can name this compound. Example number 4, Ca parenthesis NO3 with a 2 as a subscript. Calcium is in group 2A, an alkaline earth metal, so we're going to keep its name. Whereas NO3 is nitrate, is a polyatomic anion, it keeps its name as well. So let's look up NO3. There it is. So we would name this compound calcium nitrate. Now, this one is a little bit different. Example 5, CuCl2. Copper is a metal which can have different charges, so we need to find which charge we're dealing with. So copper could have a charge of +1 or +2. So we need to check out to see which one do we have here in this example. So let's do a little math. So let's rewrite it as CuCl2. So we do not know what the charge of copper is, so we're going to call it X. This is the unknown. And chlorine is in group 7A, right? Group 7A, normally they would want to gain 1 electron, so they would have a -1 charge. So chlorine have a -1 charge, but we have 2 chlorine here. So we're going to say it's X plus 2 times -1, right? 2 chlorine, each one of them would have a -1 charge. And we said the sum of the charge equal to 0 because this compound was not charged. So the sum of the charge equal to 0. And then we solve for X. So X is equal to 2. So this should be the charge for copper. The charge on copper is +2, so we name it as copper 2. And chlorine is a monatomic anion, so we change the suffix to IDE. So the name for this compound is copper 2 chloride. Example 6, FeS. Iron is a metal which can have more than one charge, so we need to look it up. So iron can have a positive 2 charge or positive 3 charge. So let's do the same thing we did in the previous example. So we do not know what iron is, so that is the unknown. We call it X. And sulfur is in group 6A, right? It would have a negative 2 charge because it's a nonmetal which would want to gain 2 electrons to achieve the octet rule. So sulfur normally would have a negative 2 charge when it's reacting with iron because it's more electronegative. So it's X plus a negative 2 equal to 0 because the sum of the charge has to equal to 0 because the original compound FeS had no charge. So X is equal to positive 2. So this would be the charge for iron when it's reacting with sulfur in this example here. Sulfur is a monatomic anion, so we change its suffix to IDE. So we would name this compound iron 2 sulfide. Example 7, COPO4. Cobalt is a metal which can have more than one charge, so we need to look it up. It could have a positive 2 charge or a positive 3 charge. Let's see which one do we have here. So cobalt is the unknown, we call it X. And PO4, that's phosphate. Normally it has a negative 3 charge. And we need to solve for X. X is equal to 3, so this is the charge for cobalt. So in this example here, cobalt has a positive 3 charge. And phosphate is a polyatomic anion. Look it up here with a negative 3 charge. And the name for this compound is cobalt 3 phosphate. Next example, we have SnO2. Sn, that's 10. So 10 is a metal which can have multiple charges. So we need to look it up. 10 could have a positive 2 charge or a positive 4 charge. So we need to find out which charge are we dealing with in this example. X is the unknown, that's for 10, and oxygen would have a negative 2 charge because it's in group 6A. And we have 2 oxygen, so that will give us a negative 4, right? X plus negative 2 times 2 equal to 0. Solve for X, X is equal to 4. So in this example here, 10 would have a charge of positive 4, so we would call it 10,4. And oxygen is a monatomic anion, so we change its suffix to IDE. So the name for this compound is 10,4 oxide. This is the end of our presentation. Please remember to like, subscribe, and share, and use the comment section to let us know if you had found the presentation to be useful. Thank you, and have a great day.